Okay, this video is about the alternating series remainder. So a remainder is how much an estimate is off by for the actual sum of a series. So if someone asked me to find the sum of a certain series, I may or may not know how to do it, but I can get pretty close, and then I can tell you the most I'm off by is some number. And alternating series are very easy to do that with. So if you look at this series, the sum from n equals 1 to infinity of negative 1 to the n minus 1 over n factorial. The first thing I would notice is that it is alternating. It will go from, if you look at plug in a 1, 1 minus 1 is 0, negative 1 to the 0 is 1, so it'll be a positive. Go up to 2, 2 minus 1 is 1, negative 1 to the first is a negative. It does alternate. So I can see that this is an alternating series. If I look at the limit as n approaches infinity of the non-alternating part, 1 over n factorial. N factorial as n approaches infinity is huge, so this actually goes to 0. It does decrease as the n's get larger. The values of the whole fraction will decrease, so it is a decreasing sequence that we have here that we're adding up. So this does converge by alternating series. The alternating series test. Okay, what the actual alternating series remainder theorem says is that the remainder will be the term after you stop. So let's say this one says estimate the sum of the series by using the first 6 terms. So if I want to estimate, I'll very simply add up the first 6 terms and find the error. How much am I off by? Well, I'm not going to find the exact error, because if I could find the exact error, I could find the exact sum, in which case I would. But what I can do is find the maximum amount of error, and the remainder theorem for alternating series says that that will be my 7th term. It's always the next term, and we'll look at this and why. So I'm going to start by getting the sum of the first 6 terms. So I'll plug a 1 in. Negative 1 to the 1 minus 1 is 1, over 1 factorial is just a 1. Plug a 2 in, and I have 2 minus 1 is 1, negative 1 to the n, so I'm going to say minus 1 over 2 factorial. 2 factorial is 2 times 1, so 1/2. Then it'll be a plus of 1 over 3 factorial, that's 1/6. 3 times 2 times 1, minus 1 over 4 factorial, and it's getting bigger quite rapidly, so this is 1/24, plus 1 over 5 factorial, so 120 times 5 would be what that is, minus 1 over 6 factorial, and this would be the estimate they're asking for. Find the estimate using the first 6 terms, so whatever this is, and if they want an actual number, I would either use my calculator or get a common denominator of 6 factorial, something like that, but add this up. So I'm going to call this S sub 6, my 6th partial sum, my estimate. Well, if you look at what's happening on the next term, so the next term would be a 1 over 7 factorial. So I know that I would add that. But on the next term, I'm going to subtract a 1 over 8 factorial, which is smaller than what I added in. So I know that what I'm off by is less than that. I'll come back, I'll add in a 1 over 9 factorial, but 1 over 9 factorial is smaller than 1 over 8 factorial, so this is still the most my error can be, and that's too much. I know my error is less than that, but this would be the max. So to find the error, you look at the next term. So I would say my remainder sub 6, my remainder after using an estimate of 6 would be 1 over 7 factorial. What that means is that I know that my actual sum would be within this fraction of this number right here. Now, one thing to note is that it doesn't matter if my next term is positive or negative. If I added this one in like I did, I would subtract out, then add back in. If I was subtracting, my next term would add it back in. I don't really care if I'm off by the small amount on the positive side or the negative side. What I want to know is how much am I off by, and this is the most my sum will be off by. So whatever this is, this S sub 6, my 6th partial sum, if I subtract 1 over 7 factorial, and if I add 1 over 7 factorial, I know that my actual sum has to be in this interval. It's my estimate minus a little bit, my estimate plus a little bit. And that's how the remainder theorem works for alternating series. So one kind of question they like to ask is approximate the sum, and then they give you an amount of error. So with a maximum error, with an error less than 0.001. And what I like to do is change this to an actual fraction. So this one is 1 over 1,000, tens, hundreds, thousands place. So I'm looking to see when my error will be less than 1 over 1,000. So to do that, I'm going to just start getting the terms of my series. So I plug in a 1. Negative 1 to the 1 plus 1 is a negative 1 squared is a 1 over 1 to the 4th is just 1. My n becomes 2. 2 plus 1 is 3. Negative 1 to the 3rd is a negative 1 over 2 to the 4th. I plug in a 3, and it's a positive 1 over 3 to the 4th. So I can see that this alternates. So if it alternates, I want to check and see if it converges or diverges. So I would take the limit as n approaches infinity of the non-alternating part, 1 over n to the 4th. That definitely equals 0. It's a decreasing series, so this would definitely converge by alternating series test. If it converges by alternating series test, then I know that I can find my error by watching the magnitude of each term. If I get to one that's smaller than 1/1000th, I know that I've probably gone a little bit too far, and you'll see what I'm talking about. So the next term would be a minus 1 over 4 to the 4th plus 1 over 5 to the 4th. And if you aren't sure about the magnitude, do a little quick math. This is 1. 2 to the 4th is 2 squared squared. So 4 squared is 1/16. 3 to the 4th is 3 squared, 9 squared, so plus 1 over 81. Minus 4 to the 4th is 4 squared squared, 16 times 16, 256. And you can see that they are growing rapidly. Plus 5 squared squared is 1 over 625, and I really know I'm there because I know the next one is going to be a fraction smaller than 1/1000th. So my next term would be a minus 1 over 6 to the 4th. Well, that's 36 times 36. And then we have, it's a 6. Not that number.